Right. Here we have an example. Find the stationary values of the following function and determine the nature of each one. So now I took this example. Why? Because it's a quadratic equation. There is something I want you to see here. I want you to observe something here. And it's a simple one so that we can quickly grasp the concept. So here, what do we do? Let y equals to 3 minus x plus x squared. So now, what do we need to do now? We need to find the first derivative. The first derivative, what do we get? It's minus 1 plus 2x. So, a stationary point, like I said, it's a turning point. It's a turning point. And the gradient of the tangent at the stationary point is equal to 0. Why? Because the tangent is horizontal or is parallel to the x-axis. So now, what do we do? At stationary point, right, dy dx equal to 0. So what does it mean here? Dy dx is equal to 0. It means what? 0 minus 1 plus 2x. So we take 1 this side minus 1 this side, we get 2x. Then x is equal to half. So we only have one turning point here. Why? Because it's a quadratic equation. So a quadratic equation always have one turning point. So now we have x is equals to half. So now we have x is equals to half. What do? We need to find the value of y. We go back to our original function. So now, when x is equal to half, we substitute y is equal to 3 minus half plus half squared. I would like to believe this is a half squared, it's a quarter. Then this is half. 3 plus half is 3 1/4 minus half. We get 2,75, which is like here 11/4 or 2.75. So at this point, y is equals to 2.75 or so. Let's say at this point, so this is our stationary point. So stationary point is equal to, we said x is equals to half and y it's 11/4. So this is our stationary point. So now we want to determine whether at this point y is it minimum or maximum. What do? We find the second derivative. Finding the second derivative, this is, we have dy dx equal to minus 1 plus 2x. So the second derivative here, what do we get? We get 2. Right. From what I said, as you can see, 2 is positive. So when 2 is positive, d squared, the second derivative is positive. So when it's positive, it means y is minimum. y is minimum. Why? Because the second derivative is true. So what I wanted you to observe, without wasting a lot of time working this, whenever you see that it's a quadratic equation, you are told to find, to determine the nature of the point, to find out is it a minimum or maximum. What you only need to check the coefficient of x squared. Check the coefficient of x squared. Whenever the coefficient of x squared is positive, know that the y has got a minimum value. Whenever the coefficient of x squared is negative, know that the y has got a maximum value. So whenever maybe you are told to sketch a graph, what you need to know, whenever the coefficient of x squared, obviously your quadratic equation will always look upwards, or will always face upwards, so that we can have the minimum value of y. Whenever you find out the coefficient of x squared is negative, your graph will always face downwards. So this is what I wanted you to observe. So for now, we can do functions with higher powers than 2. Then we'll use this method to find out whether those points, they are minimum or they are maximum, at which point are they stationary. Thank you once again for watching.